Welcome back to the Deep Dive. Today, we are going to break something. Or, well, at least we're going to try to break a metaphor that I think most of us, myself included, have been carrying around in our heads for the last few years.
It's a really pervasive metaphor.
It is, and it's one that shapes how we buy stocks, how we run our businesses, and honestly, how we think about the future of our own species.
And it's a comfortable metaphor. It makes sense to us intuitively, which is probably why it's so dangerous.
I'm talking about the idea that artificial intelligence is a brain. A super smart silicon brain floating in a digital jar somewhere in a server farm.
Right.
It thinks, it calculates, it reasons, and then it hands us an answer. It feels like this separate entity, a sovereign mind.
Exactly. We call it the computer metaphor. And it's really the default setting for how we talk about AI in pop culture, in the news, even in, business meetings. Ask the AI, like it's an oracle or some kind of super intelligent colleague.
But the stack of research we're looking at today, and we are talking about a really diverse stack here, papers from Nature Human Behavior, studies from Ethics Unwrapped, deep dives into the philosophy of technology. This research suggests that brain isn't just slightly off.
It suggests it's dead wrong.
Dead wrong. And it suggests that if you want to actually understand what these systems are doing to us, and maybe more importantly, what they're turning us into, you need to swap out that word brain for a different word.
For the word mirror.
A mirror.
A mirror. And not a particularly flattering one either. We're talking about a mirror that reflects our collective intelligence, our history, our biases, and all of our messiness right back at us. But it doesn't just reflect, it distorts.
And that is the mission for this deep dive. We really want to understand this mirror metaphor. We want to see how this reflection works, why it creates what the researchers are calling a rear-view straitjacket. And honestly, the part that's scariest for me, how staring into this mirror is actually, well, rewiring our own brains.
It's a feedback loop. We build the mirror reflects us, and then we start to change to match that reflection.
So let's just start at the beginning. Why a mirror? Why is that a better way to think about a large language model or an image generator?
Because, I have to say, when I use these tools, it feels like I'm interacting with an intelligence, not a reflection.
To understand that, you have to look at what AI actually is at a really foundational level. It's not an agent. It doesn't have intent or understanding in the way a biological creature does.
Okay.
It is an amalgamation of what one of our sources calls human symbolic residue.
Human symbolic residue. That sounds a little gross, actually.
It is a bit visceral, isn't it?
Yeah, like something you'd find in a filter trap after washing the dishes.
But it's incredibly accurate. I mean, think about what these models are trained on. They are literally fed the internet. Wikipedia articles, Reddit threads, court records, fan fiction, corporate emails, angry tweets, love letters, all of it.
Everything we've ever written down. That is the residue of human existence. The AI just processes these vast, vast volumes of historical data to find patterns.
So when I ask ChatGPT a question, it's not thinking of an answer. It's looking at that massive pile of residue and asking, based on this, what would a human usually say next?
Precisely. It's holding up a statistical reflection of what humans have said in the past. But here's the crucial catch. If you look in your bathroom mirror this morning, you expect to see you, your face, your specific features.
Right. If I see my neighbor in there, we have a serious problem.
A very big problem. The AI mirror is different. It doesn't reflect the individual standing in front of it. It reflects the collective intelligence of the specific subgroup of humanity that ended up in its training data.
It's a composite reflection.
It's an average. It's a mashup.
So it's like if I looked in a mirror and saw a mashup of every single person who has ever posted on the internet.
Which is a genuinely terrifying image if you think about some of the things people post online.
Terrifying.
Yeah.
But also probably not very accurate to who I am as an individual.
And that leads us right to the first major problem that the research identifies: distortion. This isn't a high-fidelity optical mirror we're talking about.
It's a carnival funhouse mirror.
That's the perfect analogy. It contains imperfections, warps, and cracks. It creates these huge distortions where certain demographics are looming and massive and others are shrunk down or just erased entirely simply because the underlying data is skewed that way.
But we treat it like it's a scientific instrument. We treat it like a microscope or a telescope, something objective.
And that's the danger. When you use a funhouse mirror to make serious decisions, I mean decisions about hiring, about healthcare, about who gets a loan, you are introducing a chaotic variable.
A variable you can't even see.
Exactly. But because it comes from a computer, we assume it's objective. We assume the distortion is reality.
There's a concept in the notes here that really stood out to me. It's called the narcissus effect. This feels like the psychological hook of the mirror.
It really is. Do you remember the myth of Narcissus?
The Greek hunter, right, fell in love with his own reflection in a pool of water and just wasted away because he couldn't stop looking at it.
That's the one. And AI has this incredible capability to indulge our vanities. Think about recommendation engines, Netflix, TikTok, YouTube, or even those AI companion apps like Replica.
Oh, yeah.
They are designed from the ground up to offer a compliant, algorithmically optimized reflection of your own
To
desires.
show you what you want to see. They
Mhm.
affirm what you already believe.
Exactly. They don't challenge you. They don't offer the friction of a real human relationship. A real friend might say, hey, you're being a jerk today, or I completely disagree with you on that.
The AI mirror just says, you're right, everyone else is the problem. Here is more content that proves you're right.
And so it isolates us. It creates this perfect little bubble where we are the only real person.
A feedback loop of one.
The research suggests it leads to what they call asocial proclivities. You aren't dealing with the messy, reciprocal, sometimes difficult reality of human connection. You're just staring at a flattering reflection. You become Narcissus, starving at the edge of the pool.
That's the personal level, but I want to zoom out to the societal level because there is a phrase in this research that I found even more unsettling than the narcissus thing.
Let me guess. The rear view
A
straitjacket.
rear view straitjacket, yes.
This is a crucial concept for understanding the limits of AI, specifically when it comes to time. It stems from the fact that AI is fundamentally structurally backwards facing.
Because it can only learn from data that already exists.
Correct. Data is history. By its very definition, data is a record of something that has already happened. So
Oh,
these systems act as mirrors pointing directly to the past.
okay.
Now, when we use them to make decisions about the future, we are essentially driving down the highway at 70 miles an hour.
While staring exclusively into the rearview mirror.
Exactly. And that's fine if the road ahead is a perfectly straight line that looks exactly like the road behind you. But is our future going to look exactly like our past?
I certainly hope not. Especially with things like climate change or social justice or economic reform. We're trying to change direction. We're trying to turn the wheel.
And that is precisely why it's a straitjacket. It anchors our moral and our political imagination to historical patterns. If we ask an AI for solutions to a truly novel problem like climate change, it struggles.
It has no data for the future.
It has no data for a future that is radically different from the past. It can only optimize for the status quo. It can only suggest pathways that have already been trodden.
So if the past was unjust or unsustainable, the AI is just going to keep projecting that injustice and that unsustainability into the future.
It freezes us in time. It operationalizes the past as the rulebook for the future. It's what philosophers call immobilization.
Okay, I think we need to ground this. Because operationalizing the past sounds very academic. But when you look at the case studies in our source stack, especially the ones about employment, it gets very real very fast.
It does. I mean, the classic example of this rear view straitjacket is the Amazon hiring algorithm from around 2014, 2015.
Right.
This is a case study that is cited in almost every ethics paper for a reason.
So walk us through it. This was an internal tool, right? They were trying to make hiring more efficient.
Right. Amazon creates this resume screener. The goal is pure efficiency. Amazon gets thousands upon thousands of resumes. It's impossible for humans to read them all. So they want to automate the search for top engineering talent.
Makes sense.
So they build a computer model and they train it on 10 years of resumes submitted to the company.
Which, on the surface, sounds logical. Here are the people we hired in the past who were good. Computer, go find me more people who look like that.
It's the standard best practices logic of machine learning. But what they didn't account for was the symbolic residue of those 10 years of data.
Ah, the residue again.
The tech industry, and Amazon specifically during that era, was heavily male-dominated. I think the number was something like men held 70% of the tech jobs. So the vast majority of successful resumes in that training data, the ones that led to a hire, came from men.
So the mirror just reflected that dominance.
It did more than reflect it. It turned it into a mathematical rule. The model taught itself that male candidates were inherently preferable. It didn't just look for skills like Python or management or leadership.
It started looking for men.
It started looking for proxies for men. It wasn't checking a box for gender, of course. That would be illegal.
So how did it do it?
Well, this is the tricky part with these deep learning models. The algorithm found correlations. It specifically, and this is the crazy part, it penalized resumes that included the word women's.
You're kidding.
Not at all. So if you had captain of the women's chess club on your resume,
Points it up. Downvoted. The system effectively said, this resume contains a linguistic marker that correlates with candidates we did not hire in the past. It even downgraded graduates of 2 specific all-women's colleges.
wow,
And it didn't know why it was doing it. It doesn't know what a woman is or what a chess club is. It just knew that historically, resumes with those words didn't lead to hires. It saw the pattern, men get hired here, and turned it into a rule. Men should get hired here.
that is wild. It took a descriptive reality, we hire mostly men, and turned it into a prescriptive and automated rule.
Exactly. Amazon, to their credit, they caught this. They tried to fix it. They tried to neutralize it, but they realized the bias was too deeply baked in because the bias was the data itself, and they eventually had to abandon the project.
But imagine if they hadn't caught it.
Yeah.
Or imagine a smaller company that buys an off-the-shelf version of this tool that they don't have the resources to audit.
It would just quietly enforce sexism forever. And it wasn't just Amazon, right? Google had a similar issue, didn't they?
Yeah, a similar dynamic. Google engineers trained a model on successful past candidates to find new ones. But again, you have to look at the residue.
What did it find?
Past employees were disproportionately graduates of a handful of prestigious universities and, again, disproportionately male. So this invisible bias was baked into the system from day one. It just kept replicating the past, ignoring incredibly talented people from state schools or underrepresented backgrounds because they didn't fit the historical reflection.
They didn't look like the past.
Exactly. And there's also that study about ad delivery. This one really creeped me out because it's so invisible, you would never know it was happening to you.
Oh, the Google Ads study, this was fascinating. Researchers created a bunch of fake web users. They were identical profiles, same interests, same browsing history, same location.
A one difference?
The only difference was the gender tag. Some were marked male, some were marked female.
And then they just let them loose on the web?
They let them surf and just meticulously tracked what ads were served to them. And they found that the fake male users were shown ads for high-paying executive jobs significantly more often than the equivalent fake female users.
So the algorithm just decided high-paying jobs are for men and didn't even show women the opportunities.
Think about the massive economic impact of that over a population. If you never see the ad, you can't apply for the job. The mirror reflects the economic reality of the past, where men hold more executive roles, and it imposes it on the present, ensuring that women have fewer chances to change that reality.
It's a self-fulfilling prophecy machine.
Precisely. It narrows the funnel before a human being even gets involved in the decision.
But, okay, those are jobs. If you miss a job ad, that sucks, but it's not life or death. The healthcare examples in our source stack, I mean, those are literally life or death.
This is where the stakes get incredibly high. There was a landmark study that looked at algorithms used to allocate healthcare resources in the United States. And these systems affect millions of people.
What are they used for?
They're used by insurance companies and hospitals to decide who needs extra care, who needs a dedicated nurse case manager, who is considered high risk.
So the goal is to help the sickest people. It sounds benevolent.
That's the intent, absolutely. But the algorithm had a problem. It couldn't measure sickness directly. You can't just, stick a thermometer in a database.
Yeah.
So the developers had to use a proxy,
A proxy.
a stand-in.
A stand-in. A variable that they hope represents the thing you actually want to know. And in this case, they used healthcare spending as a proxy for medical need.
The logic being,
The logic was, if you're sicker, you spend more money on healthcare.
which sounds reasonable, I guess. In a perfect world, if I have cancer, I'm definitely spending more than if I just have a cold.
In a perfect, equitable world, yes. But we don't live in a perfect world. We live in a world with deep, historical, systemic inequalities in healthcare access.
Historical data shows that Black patients often face massive barriers to access. They frequently receive less care or lower-cost care for the exact same conditions compared to white patients. Maybe they live further from top hospitals, or they're underinsured, or systemic bias from doctors leads to fewer tests being ordered. The reasons are complex.
So, because the system spent less money on Black patients in the past.
The algorithm looked at the data and said, oh, this patient hasn't spent much money, they must be healthy.
Oh, no.
It concluded that Black patients were healthier than white patients who had the exact same biological conditions. We're talking kidney failure, diabetes, heart disease.
So, It denied them the extra help they needed.
It drastically under-referred Black patients for these critical care programs. Because the mirror didn't reflect biological reality, it reflected the economic reality of a biased and unequal system.
That is genuinely terrifying. It's essentially an automated system for saying, we neglected you in the past, so the computer says we should continue to neglect you in the future.
That is the rear-view straitjacket in its most brutal form. And the worst part is, from a purely mathematical standpoint, the algorithm was correct. It accurately predicted future spending. It just failed to realize that spending is a deeply flawed proxy for health. It reflected the spending gap and interpreted it as a health gap.
Okay, I need to take a breath after that one. So to recap, AI picks up our bad habits, it learns our biases, it projects them forward. That's bad enough. But here is where the research takes a turn that I really wasn't expecting. It moves from bias in to bias amplification.
This is the snowball effect. This is where it gets really scary.
You have this study here from Nature Human Behavior that dives right into this human-AI feedback loop. And this implies that the AI isn't just copying us, it's actively making us worse.
This is a crucial piece of research because it asks a very simple question. When humans interact with a biased AI, what happens to the humans? Do we correct the AI, or does the AI corrupt us?
So walk us through the experiment. How on earth do you even test that?
They used a classic psychological task, classifying faces. They showed participants an array of faces, some smiling, some frowning, some very ambiguous, and they asked them to make a simple judgment. Does this group of faces look more sad or more happy?
Seems simple enough. Subjective, but simple.
Then they introduce an AI into the mix, but first they train the AI on human data that has a very slight bias. The humans in the original training set had this tiny tendency, about 53%, to see the ambiguous faces as sad.
Okay, so a tiny human pessimism bias. Basically a coin flip, but just slightly weighted towards sad.
Right, barely noticeable, but when the AI learned from this data, it didn't just copy the 53%, it amplified it. The AI started classifying 65% of the faces as sad.
Whoa, wait, why? Why does it exaggerate? That doesn't seem logical.
It's all about the signal-to-noise ratio. An AI's goal is to maximize prediction accuracy, to be consistent. So if it detects a pattern, even a small one like humans tend to say sad, it latches onto that pattern to make its own predictions more consistent. It tries to reduce the noise of human variability and amplify the signal of the bias.
So it wants to be certain, and the bias is the most certain thing it can find in the messy data.
It wants to be right, so it doubles down on the dominant trend.
Okay, so the AI is now a drama queen. It thinks everyone is sad all the time. But here's the big question. What happened when new, unbiased humans started interacting with this drama queen AI?
That is the absolute kicker. When new human participants performed the task and were shown the biased AI suggestions, they adopted the bias, and not just a little bit. In this human-AI interaction loop, the human participants became significantly more biased over time. They moved from their baseline of around 50-50 all the way up to being 61% biased toward sad.
They caught the infection from the machine.
They did. And here is the most important part of the whole study. This amplification did not happen in human-to-human interactions. When humans looked at biased suggestions from other humans, they didn't spiral. They sort of stayed grounded. But with AI, they spiraled.
Why? Why do we trust the machine more than we trust each other?
Perception. We perceive AI as superior, as objective, as mathematical. The study found that AI judgments are extremely consistent. They're far less noisy than human judgments. And this high signal-to-noise ratio makes us learn from them much faster, even if the signal is completely wrong.
So we subconsciously think, well, the computer must know something I don't.
That's exactly it. In fact, they did a variation of the study where people thought they were interacting with an AI even if it was actually a human on the other end, and they still learned the bias more strongly. It's the authority we give to the label AI. We just turn off our critical thinking because we assume the machine has already done the thinking for us.
That brings us directly to the Stable Diffusion experiment that's mentioned in the source material. This takes it out of the lab and into the visual world we all live in now.
Right. This is much more visceral than just sad faces. This experiment involved giving the financial manager prompt to Stable Diffusion, a very popular image generator.
The prompt was just a financial manager.
That was it. And researchers asked it to create images based on that prompt.
Let me guess. It wasn't a very diverse group of people.
Not at all. The resulting images were 85% white men.
85%. That's Well, that's a lot.
It's a massive overrepresentation compared to reality,
Yeah.
even in a field that isn't perfectly balanced. But the really scary part is what happened to the humans who saw these images.
Okay.
After participants viewed these AI-generated pictures, they were given a separate test where they had to select a financial manager from a lineup of different people.
Yeah.
And they were significantly more likely to select white men. The AI's distorted mirror directly warped their own perception of what a financial manager looks like. It changed their mental model.
And the real kicker, going to the notes here, is that they didn't even realize it was happening.
Correct. Participants consistently underestimated the AI's influence on them. They didn't feel like they were being brainwashed or manipulated. They just quietly, subtly shifted their worldview to match the machines. They thought they were making their own rational choice, but their baseline for what's normal had been moved.
The mirror told them, this is what success looks like, and they just believed it.
They absorbed it.
That is so subtle and so dangerous. It's not just about images, though. This feedback loop is happening in our jobs, too. We need to talk about the algorithmic boss.
This is a huge shift in the modern workplace. We are seeing the rapid rise of what's called algorithmic management, using AI to assign tasks, optimize delivery routes, and evaluate worker performance.
Like Uber drivers or Amazon warehouse workers.
It definitely started in the gig economy, Uber, DoorDash, that kind of thing. But it's quickly moving into white-collar jobs, call centers, data entry, even project management and software development. And it's causing what researchers are calling algorithmic thinking in humans.
What is algorithmic thinking? It sounds like we're just becoming robots.
It's a fundamental rewiring of our cognition. For one thing, it leads to something called decision paralysis.
Yeah.
Workers get so used to the AI telling them the optimal route or the best answer to a customer query that they lose confidence in making their own independent choices. When the system is turned off or unavailable, they freeze up. They don't trust their own judgment anymore.
It's like forgetting how to do long division, because you always have a calculator, but for complex real-world decisions.
That's a great analogy. And it also creates quantification bias. The human brain starts prioritizing things that the algorithm can measure: key performance indicators, click-through rates, efficiency scores.
The numbers.
The numbers. And the qualitative things like employee well-being, creativity, mentorship, or just good team vibes, they get ignored because the AI doesn't measure them. So if the mirror doesn't reflect it, it effectively stops existing in the managed workplace.
There's a term here that I relate to way too much. Emotional delegation.
Oh, this one is fascinating. This comes from the AI as a mirror source material. It's the idea that we're increasingly outsourcing our own self-perception to algorithms. Think about Spotify Wrapped at the end of the year telling you what your personality was like.
Or sleep tracking apps. I do this. I wake up, I feel okay, but then I check my watch and it says, sleep score, 40%. And suddenly I feel exhausted.
That is emotional delegation in a nutshell. You are trusting the digital judgment of the machine over your own intuition, your own felt sense. It's a form of what they call cognitive disengagement.
I'm letting the data tell me how I feel.
You become estranged from your own emotions and physical states because the data says otherwise. You're asking the mirror, how do I feel today, instead of asking yourself.
So are we literally rewiring our brains?
Yeah.
Or is that just a metaphor for a metaphor?
The evidence suggests it's literal. We know about neuroplasticity. Our brains physically adapt to what we do repeatedly. The famous study is the one on London taxi drivers.
Right, they have to memorize the knowledge.
Exactly, that huge map of all the streets in London. And because of that, they develop larger hippocampi, the part of the brain responsible for spatial navigation. Their brains physically change to match their job.
So if we spend all day, every day, interacting with algorithmic logic,
It's very likely that we're developing neural structures that are optimized for that specific type of logic.
at the cost of what? What are we losing?
Potentially at the cost of things like emotional intelligence, abstract thinking, and creativity. There's already research correlating heavy exposure to algorithmic management with lower scores on standardized creativity tests. We are narrowing our neural pathways to match the machine. We are becoming more like the tool we use.
Wow, that is heavy. We are shaping the machine, and the machine is shaping us right back. But I want to zoom out for a second. We talked a lot about data bias, the residue, but there's another deeper layer here. It's not just the data, it's the architecture of the AI itself.
Right. This is a key point. We tend to think that if we just fix the data, get more diverse resumes, more balanced faces, the problem will go away. But one of the papers from Amazon Science discusses something called inductive biases.
Inductive biases. That sounds pretty technical. What does it mean in simple terms?
It just means that there are assumptions baked into the code itself. Before a single piece of data is ever added, the architecture has its own rules about how it should learn. A common one is called smoothness bias.
Smoothness bias.
It's the built-in assumption that similar inputs should produce similar outputs. If you like vanilla ice cream, the computer assumes you will probably also like vanilla bean, not, hot sauce.
That just sounds like common sense.
It is, for a computer.
Yeah.
But it means that objectivity is a myth, even at the deepest level of the code. The architecture itself forces the world to fit into these smooth, local, hierarchical boxes. It's like it frames the mirror before the reflection even appears.
And it hates things that don't fit.
It hates discontinuity. It hates randomness. It hates surprise. But human life is full of discontinuity and randomness and surprise.
So the code itself imposes an order on the world where there might not be any.
Exactly. And this frame, this order, looks different depending on where you are in the world. We have sources here comparing Western AI models to Chinese models, and the differences are stark.
The geopolitics of the mirror.
That's a great way to put it. Research comparing large language models from the West and from China shows a really sharp divergence in values.
How so?
Well, Western models, like the ones most of us use, ChatGPT, Claude, and so on, they tend to prioritize what's called operator intent.
Meaning they do what the user asks them to do.
Right. They're built to follow instructions, and they reflect very U.S.-centric values, the Protestant work ethic, individualism, a dominance of the English language, and its cultural assumptions.
In the Chinese models.
They're embedded in a very different governance model, one that's focused on social stability and harmony. And the research shows they have much higher consistency in what's called hierarchical value orientations.
So the AI in China isn't just reflecting Chinese data. It's reflecting an ideology of stability and social hierarchy.
Precisely. And the Western AI is reflecting an ideology of individualism and user intent. The major implication here is what some call digital fragmentation. We aren't building a single universal brain. We're building regional mirrors.
So we're heading for a world where truth, or at least the AI-generated version of it, depends entirely on which server your request happens to hit.
That seems to be the direction we're headed.
So let's try to recap this entire journey because it's been a lot to take in. We started out thinking AI was a brain. We quickly realized it's a mirror.
A funhouse mirror at that.
A funhouse mirror that reflects our past biases, freezes our future with that rear-view vision, and actively changes who we are through these insidious feedback loops. It's making us more biased, less creative, and maybe even changing our actual brain structure.
That sums it up pretty well.
Yeah. So what do we do? Do you just smash the mirror?
I don't think we can smash the mirror. AI is here to stay. It's too useful. It's too integrated into our economy, into our lives. But we can learn to clean it. And more importantly, we can change what is standing in front of it. As one of the sources says, to improve the AI mirror, we must first improve the society it reflects.
That sounds like a pretty big job. Fix society. Thanks for that.
Okay.
But are there practical, concrete steps that we can take?
There are. The research actually outlines 3 main strategies. First, audit the reflection. We need regular, rigorous probing for proxy discrimination. We need to catch that healthcare spending equals health error before it denies someone critical care. We need to constantly ask, what is this AI actually measuring?
So stop the proxy problems. Don't let money stand in for health or gender stand in for skill.
Second, broaden the perspective. We absolutely need more diverse training data, yes, but just as importantly, we need more diverse developer teams. If everyone building the mirror looks the same, acts the same, and went to the same 3 universities, the mirror is only going to reflect them. We need more eyes on the code, more perspectives in the room.
And third, what's the last one?
Break the real view loop. And this is the hardest one by far. We need to develop what some are calling moral graphs that prioritize aspirational virtues over historical statistical patterns.
What does that mean?
It means we need to explicitly tell the AI, this is what we want to be, not just what we were. We need to code for fairness, for justice, for sustainability, even if the historical data doesn't reflect those values perfectly.
So we need to teach it to look forward, not just backward. We need to code for the world we want, not just the world we have.
Exactly. We have to be the adults in the room. We can't just let this toddler machine learn from all our bad habits and then act surprised when it behaves badly.
That is a very powerful idea.
Ultimately, reclaiming our own humanity requires recognizing that we are not talking to a new kind of mind. We are talking to ourselves through a digital medium. The old question was, can the machine think? That's not the question anymore.
What's the new
The
question?
question is the society reflected in the machine the one we actually want to be?
That is the question of the century. And maybe here's a final thought for you to chew on as you go about your day. The next time you ask an AI a question, or you look at an AI-generated image, or even just check your sleep score, ask yourself, who is looking back at you? Is it an objective truth? Or is it a reflection of a million past decisions nudging you quietly to make the same choice one more time?
Look in the mirror, both the digital one and the analog one, a little differently today.
Thanks for listening to The Deep Dive. We'll see you next time.